Hi, this is Jessie Sparks. This is YouTube video number 3. My compound is rosuvastatin, and as you can see, this is the skeletal structure for rosuvastatin. And in this video, we're going to talk a little bit about the mass spec aspects of rosuvastatin, and then also the H1 NMR and the C13 NMR for rosuvastatin. So this is the mass spec for rosuvastatin. The mass spec is an analytical chemistry technique that helps identify the amount and type of chemicals present, and it does it by measuring the mass to charge ratio and abundance of a gas phase ion. So you would put a sample into a mass spectrometer and it would bombard the sample with a stream of electrons, and if these electrons have a high enough energy, they will knock an electron off of the organic molecule to form a positive ion, and this positive ion is called the molecular ion. And as you can see on this peak right here, this 478.2, that's the molecular ion for rosuvastatin. And these molecular ions tend to be unstable and will break into fragments, and the heaviest ion is likely to be, or more likely to be, the molecular ion. So that's the mass spec for rosuvastatin, and this would be the H1 NMR for rosuvastatin. And H1 NMR is really just the application of the nuclear magnetic resonance to the H1 nuclei within the molecules to determine the structure of the molecule. So it basically looks for where in the structure the H1 ions are. And for for this structure, they're located at 23 parts per million, 1.40, between 4.32 and 4.81, 7.30, 8.15, and 10.25. So this isn't really just the one for just rosuvastatin, but you can see that there's a peak for rosuvastatin right here at what would be right around probably the 1.7 mark. And within the H1 NMR, there's something called the chemical shifts, which are the resonant frequencies of a nucleus relative to a standard. And the position and number of chemical shifts are pretty much diagnostic of the structure. And with rosuvastatin, there are downward shifts due to the de-shielding effect that comes from the presence of hydrogen bonds. So that's pretty much the rundown of what would be the H1 NMR for rosuvastatin. The last part would be the C13 NMR for rosuvastatin. And C13 NMR is pretty much the same as H1 NMR, only it looks for carbon atoms instead of hydrogen atoms. So you can see the graph down here that shows where the peaks would be for the C13 NMR for rosuvastatin. And with the C13 NMR, it would only pick up C13 NMRs because they have a spin on their atoms that C12 isotopes don't. So that's why it can pick up C13 instead of C12. So that's all. Thank you.